Kia ora Year 12 and Year 13. This is a really nice question from the 2010 Scholarship Calculus paper, and it's one that you can do with just level 2 differentiation and a little bit of common sense. That's a good warm-up problem. The question goes like this. So as usual, make sure you pause the video here and have a really good go at it on your own before I go through it. So we've got 3 parabolae here. The first thing to do obviously is to figure out which one is which. So we've got this one here, which is our basic parabola translated a units that way. So this parabola here is the first one. The next one is the basic parabola translated left by a units, so it's there. And this last one here is y equals bx squared minus k, right? So it's got a stretch factor, an outwards stretchy factor, and then it's been shifted downwards by k units. And we're told that the third parabola meets each of the others at a point with a common tangent line. And we're going to use both of those ideas in here. Now, what we've got to do is to find k in terms of a and b. So I'm just going to grab the ruler and try and put in that common tangent line. I'm going to work with just the parabola over here and do the rest of the question by symmetry. So there's my common tangent line. You don't have to draw that in, but hopefully that prompts you to do a couple of things. Notice that we're looking for the gradient of the curves, wow, what a mess I'm making, to be equal. And we also know that that's going to happen at a point, and a point has x and y coordinates. So my strategy is going to be this. First of all, find the gradients. So the gradients are equal, so we're going to solve something with that. And then we're going to solve for x, and then get k equals using, as it turns out, the y value. But you don't know that when you start. So when you start a problem like this, all you really know, if you're me, is where to start. So we're going to start by looking at what happens when the gradients are equal, and then moving through the question from there. So step 1, the gradients. Well, first parabola we've got is y equals x minus a squared. So dy by dx is equal to 2 times x minus a, or 2x minus 2a. And parabola, I'll call it parabola 3, the shifted down one, is y equals bx squared minus k, giving me dy by dx is a very straightforward 2bx. So equating those gradients, what do we get? Well, we have 2x minus 2a is equal to 2bx. So I'll divide through by 2. X minus a is equal to equal to bx. Collecting like terms, we have x minus bx is equal to a. And I can now solve that for x. So x is equal to a over 1 minus b. Right, now let's go back and think about what were we asked to do. Well, we have to figure out k in terms of a and b. So what we've now got is the x coordinate here. So x is equal to a over, oops, that's not right, the x coordinate here. So x is equal to a over 1 minus b. Now, there's no k in sight. The only place that k comes in this question is in my equation for the third parabola. So what I now need to do is to take that x value and figure out the coordinates of the point where the two tangent lines meet. I'm going to do that by using the equation for this one and for this one. And now we're going to equate the y values. Right, so we know that there's this point here. I'm just going to get rid of some of this big mess. Let's see, we'll get rid of some of this. Right, so we've got this point, and we know the x coordinate is a 1 minus b, and we want to now figure out what the y coordinate is. And the y coordinate is going to be the same whichever of these two equations we get. So we're going to equate the two y coordinates and then solve for k. So the first one has equation, let's see, so it's x minus a squared, and equation 3 gives me y is equal to b x squared minus k. Right, so let's just do a little bit of algebra. I'm going to get a common denominator here. So we've got 1 minus b that is equal to b a squared over 1 minus nearly there. And what I want to do now is, because I know I'm trying to get an expression for k, we can write it as follows. So k is equal to ba squared over 1 minus b squared minus, let's see, I want to do something here, minus a times 1 minus b squared over 1 minus b squared. Cleaning that up, we get our common denominator of 1 minus b squared, and then ba squared minus, now let's have a look at the numerator here. It's not nearly as bad as it looks. It's a, take away a, plus ab squared. So k is rapidly cleaning itself up. We've got ba squared minus a squared b squared over 1 minus b squared, which simplifies to b a squared times 1 minus b. So that's the final answer. So there's an expression for k. All right, leave me a comment if you've got any questions. Otherwise, it's just a really nice little algebra question to get started with. Thanks for watching.